Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi. In this lecture video, we want to focus on the topic Vogel's approximation method. Note that Vogel's approximation method is one of the methods that we can use in order to find an initial basic feasible solution. This method is preferred over the northwest corner method and the least cost method because the initial basic feasible solution obtained by this method is either optimal solution or very near to the optimal solution. Generally, there are 6 basic steps that you have to perform in order to find the solution by using the Vogel's approximation method. I will demonstrate these steps through 2 different examples. Let us consider example 4.4. In example 4.4, you need to obtain the initial basic feasible solution using the Vogel's approximation method for the following transportation problem. So what you have to do, you need to compute row penalties and also column penalties. So what we have to do actually is you need to focus on the values or the cost values in the blue box. Okay, first of all, let us focus on the first row. In the first row, the smallest value is 10 and the next smallest value is 19. So what you have to do is you need to find the difference. So 19 minus 10 is 9. So 19 minus 10 is 9. Sorry, 9. And then let us look for the second row. For the second row, the smallest value is 30 and the next smallest value is 40. So the difference 40 minus 30 is 10. Therefore, we have here 10. The third row, we have the smallest value is 8 and the next smallest value is 20. So 20 minus 8 is 12. Therefore, we have here 12. Next, we look for the column penalties. Let us consider the first column. In the first column, the smallest value is 19 and the next smallest value is 40. 40 minus 19 is 21. Therefore, we have here 21. Next column. The smallest value is 8 and the second smallest value is 30. So 30 minus 8 is 22. Therefore, we have here 22. Next column. The smallest value is 40 and the second smallest value, the next smallest value is 50. So 50 minus 40 is 10. So here we have 10. And for the final column, we have the smallest value is 10 and the next smallest value is 20. So the difference 20 minus 10 is also 10. So here 10. And then among all these values, you need to identify the largest, where in this case, the largest is this one, 22. So since 22 is the largest, where 22 is for the second column, so what you have to do, you need to look at the cost values in the second column and then identify the value that has the lowest or the minimum value, where in this case 8 is the minimum value among the 3 values, 30, 30 and 8. So we have 8 is the minimum. So what you have to do, we will allocate a value here, and we need to compare because this value is in the second column and the second column and the third row. Therefore, you need to compare the demand value in the second column with the supply value in the third row. So here we have between 8 and 18, we have 8 is the minimum. So we will allocate 8 here. So 8 minus 8 is 0, and then 18 minus 8 is 10. And since we have here 0, then we will delete the second row, the second column. So we will delete the second column. Here, delete the second column. So now, the next step is we want to calculate again row penalties and column penalties based on the undeleted cells. So what we will do, we will compare from the first row. We need to compare these three values where the smallest is 10 and the next smallest value is 19. So 19 minus 10 is 9. Therefore, we will have here 9. For the second row, we have the smallest value is 40 and the next smallest value is 60. So 60 minus 40 is 20. Therefore, we have here 20. And then for the third row, we have the smallest value is 20 and the next smallest value is 40. So 40 minus 20 is 20. Here 20. Next I'll erase this 20. Next we look at the column in order to calculate the column penalties. From the first column here, we have the smallest value is 19 and the next smallest value is 40. So 40 minus 19 is 21. Therefore, we have here 21. Next, we consider the third column, where in the third column, you have the smallest value is 40 and the next smallest value is 50. So 50 minus 40 is 10. So we have here 10. Okay, for the second column just now, we don't compute anymore the column penalty, so we just put dash. And then for the fourth column, we have the smallest value is 10 and the next smallest value is 20. So 20 minus 10 is 10. So 10. Okay, now among these values, among the row penalties and also the column penalties, find the largest value. And in this case, the largest value is 21. So what we have to do next is we have to compare these three values because 21 is located in the first column. So we compare these values. And among these three values, The smallest is 19. Therefore, we will allocate a value there. So we will allocate a value here where we need to compare between the supply value and also the demand value. Therefore, we have here, just now we compare 7 and 5. 5 is less than 7, so we will choose 5. We will allocate 5. 5. Okay. 5 minus 5 is 0. 7 minus 5 is 2. So since we have here 0, then we will delete the first column. So delete first column. So now the remaining cells are only this one. Okay, so we have delayed the first column. Therefore, we won't compute the column penalty for the first column. So we put dash, and we also deleted the second column. So we put dash. Okay, now we perform the process again. So for the first row, because we just have two values now, so you just have to find the difference based on the two values. So 50 minus 10 is 40. 40. And then for the second row, we have 60 minus 40 is 20. And then for the third row, we have 70 minus 20 is 50. And then for the columns, we have among these three values, the smallest is 40 and the next smallest value is 50. So 50 minus 40 is 10. So 10. And then for the fourth column, we have the smallest value is 10 and the next smallest value is 20. So 20 minus 10 is also 10. So now you have to compare these values and these values. And among these five values, the largest is 50. So the largest now is 50. Therefore, we will look at the cost values from the third row. And between 20 and 70, 20 is the least or the minimum. Therefore, we will allocate a value to this cell. Okay. So we allocate a value here where we need to compare 10 and 14. Where 10 is less than 14, therefore we will allocate 10. We'll allocate 10. So 10 minus 10 is 0. 14 minus 10 is 4. And since we have 0 for the third row, then we will delete the third row. Okay, now, based on the remaining cells, let us look at the first row. Okay. We have 50 minus 10, because just two values. So 50 minus 10 is 40. Okay. And then 40. And then for the second row, we have 60 minus 40 is 20. And because we deleted the third row, so we put dash for the row penalty for the third row. We also deleted the first column and also the second column. And then we have to compare 50 and 40. So 50 minus 40 is 10. Therefore, we have 10 here. And then we look at the final column. 60 minus 10 is 50. So 50. And now, based on these four values, the largest is 50. So we will look at this row. And between 10 and 60, 10 is the smallest. So we will allocate a value to this cell. We allocate a value to this cell. Therefore, you need to compare the value here, 2 and 4, where 2 is less than 4, so we will allocate 2. 2 minus 2 is 0, and 4 minus 2 is 2. So because we have here 0 for the first row, then we will delete the first row. Okay, the next one, because we just the cost values left only 2 values, then you just have to compare which one is the smallest, and in this case 40 is the smallest. Therefore, we will allocate first a value here where we need to compare 9 and 7. So 7 is less than 9, therefore we allocate 7. 7 minus 7 is 0. 9 minus 7 is 2. And because here we have 0, then we will delete the third row. And we still have values for the supply and the demand, 2 and 2. And of course, we need to allocate this value to the final cell. Therefore, here we put 2, because 2 minus 2 is 0, and 2 minus 2 also 0. So when you get when you get everything 0, this one and this one, then that's mean we have completed the calculation. So what's next? So now you want to give the initial basic feasible solution. Initial basic feasible solution, where we want to compute the total cost, where the total cost is how we want to compute it. What you have to do is 19 times 5 plus 10 times 2 plus 40 times 7 plus 60 times 2 plus 8 times 8 plus 20 times 10. Okay. So here we have 19 times 5 plus 10 times 20 times 2 plus 40 times 7 plus 60 times 2 plus 8 times 8 plus 20 times 10. Thus, the answer is, if it is in RM, then RM 779. Now, let us consider example 4.5. The transportation problem that we want to consider in example 4.5 is the same transportation problem that we have considered in example 4.1 and also example 4.3. In example 4.1, we have used the northwest corner method. And in example 4.3, we have used the least cost method. In example 4.5, I want to demonstrate by using the Vogel's approximation method. And later, we will compare the results based on 3 different methods that I have mentioned just now. So what you have to do here is you need to compute the row penalties and also column penalties, where in order to do this, you need to look at the cost values in the blue box. So let us consider the values in the first row. In the first row, we have the smallest value is 2 and the second smallest value is 4. Thus, 4 minus 2 is 2. Next, we consider the second row. In the second row, we have the smallest value is 1 and the next smallest value is 3. Then 3 minus 1 is 2. For the third row, we have the smallest value is 4 and the next smallest value is 5. Then 5 minus 4 is 1. In the fourth row, we have the smallest value is 1 and the next smallest value is 2. Then 2 minus 1 is also 1. Now, let us consider the columns. For the first column, we have the smallest value is 1 and the next smallest value is 2. Thus, 2 minus 1 is 1. In the second column, we have the smallest value is 3 and the next smallest value is 4. Thus, 4 minus 3 is 1. Next, we consider the third column. In the third column, we have the smallest value is 1 and the next smallest value is 2. Thus, 2 minus 1 is 1. So now, what you have to do next is you have to consider the penalties values both in the column, for the column and also for the rows. So among all these values, highlighted in pink, we have 2 maximum values, which are this one and this, where these two values of 2, we have them in the first and second row. So we have to consider the first and second values for the cost. And among these 6 values, we can see that this is the smallest. So we will consider the cell here. So since we want to consider this cell, then that means we base on these two. Okay, so we will allocate a value here, because just now we know that the smallest based on these 6 values is this one. Then we will allocate a value here based on the supply value, this, and the demand value, this. So 8 and 18, 8 is less than 18, then we will allocate 8 to the cell. So here we have 8. So 18 minus 8 is 10, and 8 minus 8 is 0. And since we have 0 here, then we will delete the second row. We'll delete the second row. Okay. So again, we have to follow the same procedure as we did just now, but now we base on the cost values for the undeleted cells. Let us consider the first row again. So the smallest value is 2 and the second smallest value is 4. Then 4 minus 2 is 2. We have deleted the second row. Then we will consider next is the third row here, where the smallest value is 4 and the next smallest value is 5. So 5 minus 4 is 1. Just now we have deleted the second row, so we just put dash. And then for the fourth row, we have the smallest value is 1 and the next smallest value is 2. Then 2 minus 1 is 1. Next, consider for the columns. For the first column, we have the smallest value is 1 and the next smallest value is 2. Thus, 2 minus 1 is 1. For the second column, we have the smallest value is 4, the next smallest value is 6, then 6 minus 4 is 2. For the third column, we have the smallest value is 2 and the next smallest value is 4, thus 4 minus 2 is 2. So now, among these 6 values, the maximum that we have is 2. But here we have 3 values of 2, which are this one, this, and this. So what we have to do now is we need to consider first these two, where these two is based on the first row, and then for these two based on the second column, and these two is for the third column. And among all these values, the least is 2 and 2. Okay. So the next thing, because we have a tie here, 2 and 2, we need to consider the maximum allocation based on the supply and demand. If we are considering this, sorry, I'll delete first. If we are considering these two, then the maximum value that we can allocate is based on 5 and 7. Then we should allocate here, the least will be 5. And then if we want to consider this one, then the maximum that we can allocate is based on this and this. Then we can, because 10 is less than 14, so we can put here 10. And since 10 is larger than 5, so we will consider this one. So that's mean we base on these maximum values. So I'll delete everything first so that you won't get confused. Okay, just now we know that we want to consider this value. So, and we also know that we will consider this cell, and the maximum that we can allocate is 10. So 10 minus 10 is 0. 14 minus 10 is 4. And since we have here 0, then we now delete the third row. Sorry, the third column. Okay, next. Again, we will perform the same process, but now we will consider the remaining cells, where in the first row, now we just have two values, so you just find the difference, where 7 minus 2 is 5. And then for the for the third row, we have 5 minus 4 is also 1. And just now we have deleted the second row, so we just put dash. Sorry, dash. Here 1. And then for the third row, sorry, not third row, fourth row, we have 6 and 1. So 6 minus 1 is 5. So 5. Okay, next we will consider the columns. In the first column, we have the smallest value is 1. The next smallest value is 2. Thus, 2 minus 1 is 1. In the second column, we have the smallest value is 4. The next smallest value is 6. So 6 minus 4 is 2. And we have deleted the third column, so we just put dash. And then next, you have to identify the largest value from the values highlighted in blue. So here, the highest, we have two values here, which are this and this. So that means you have to consider the second. Okay, we have these. We have these two are the largest. So we need to consider the first row and the fourth row. So among the values in the first row and the fourth row, we have the smallest is 1. So we will consider that cell. Thus, we will allocate a value here based on the supply value and the demand value. 4 and 7. 4 is less than 7. Thus, we will allocate 4. So now 4 minus 4 is 0. 7 minus 4 is 3. And since we have 0 for the supply is 0 for the fourth row, then we will delete the fourth row. Next, we will compute again the penalties for the row and also for the column. In the first row, for the remaining cell only, okay? In the first row, we have 2 and 7. So 7 minus 2 is 5. And then for the third row, we have 5 and 4. Thus, 5 minus 4 is 1. Okay, for the second row, we have deleted it. So just put dash. And then we also have deleted the fourth row. So we also put dash. And then next, we will consider the columns. In the first column, the remaining cells are in the first row and also in the third row, which are 2 and 5. So 5 minus 2 is 3. in the second column, we have 7 and 4. So 7 minus 4 is 3. Sorry. And we have deleted the third column, so we just put dash. So now we identify the largest value from these penalties. This one and this one. So the largest here is 5, which is this one. And from there, just now I forgot that we considered this one, right? Okay. And from there, then we have to consider this one. So between 2 and 7, 2 is less than 7, so we will allocate a value here, where we have to look at the supply value, this and this. So between 3 and 5, 3 is less than 5, thus we will allocate 3. So 3 minus 3 is 0, 5 minus 3 is 2. So since we have here 0, then that's mean we can delete the first column. So now we just have 2 cells left, 7 and 4. Between 7 and 4, 4 is less than 7, so we will consider 4. So we will allocate a value here, and we need to compare the supply value and the demand value. So 7 is less than 9, so we will put 7. 9 minus 7 is 2, and 7 minus 7 is 0. And since we have here 0, thus we can delete the third row. So the only cell left is this one. This one. So, and we still have these non-zero values for the supply and demand. So we have to make sure that everything will be 0. Then what you have to do is we will allocate a value to this last remaining cell. So we need to put 2. So 2 minus 2 is 0. 2 minus 2 is also 0. Then now we have 0, 0. And the values in the supply and also in the demand, the values in the supply column and the demand row now is 0 for all. So that's mean we have completed the steps. So the next thing that we want to do is we want to compute the initial basic feasible solution, where actually we want to compute the total cost, where in order to compute the total cost, what you have to do is we base on the cells that we have allocate values. So what we have to do is 2 times 3 plus 7 times 2 plus 1 times 8 plus 4 times 7 plus 1 times 4 and plus 2 times 10. Thus, the total cost will be 2 times 3 plus 7 times 2 plus 1 times 8 plus 4 times 7 plus 1 times 4 plus 2 times 10. And if the cost is in ringgit Malaysia, then we should have RM 80. Okay, if you refer back to example 4.1 and example 4.3, example 4.1 and example 4.3. In example 4.1, we use the northwest corner method, and in example 4.3, we use the least cost method. And the total cost by using the northwest corner method, I mean the initial total cost that we obtained was RM 102. And when we use the least cost method, the initial total cost was RM 83. Okay, if you compare these three values, the list is this one. So that's mean the Vogel's approximation method gives an initial basic feasible solution that is close to optimal or maybe optimal solution. Alright, that's all. Thank you. Bye-bye.